Section 4.3, proportions and percentage. So in this particular lecture video, let's take a look at solving percent problems using equations. The proportion part is going to be the next video where we do a lot of, where we're going to do some example back regarding to proportions, and we're going to include some percentage as well. All right, so here I have three equations that we commonly use. In order to find part, we basically take percent times the whole. So where the percent got to be in decimal notation. Whenever we want to find percent, all right, we take the part divided by the whole, all right, and times 100. And in order to find whole, we will always take part divided by the percent, where the percent got to be in decimal notation. Okay, no percent got to convert it into decimal first. So basically, when it comes to percent type of word problems, we normally look for one of the three things: part, percent, or the whole. All right. So let's take a look. This is a very important concept. Let me kind of type it out. So percent, normally we say percent is a part over the whole. All right. So it's basically what this thing is saying. Percent is equal to part over the whole. All right. So sometimes when we use this phrase, we are talking about percent is always part divided by the whole. But this from part right here, this from piece of the saying, percent always representing a part of something. Percent always representing a part. So anything that is less than 100%, okay, is always regarded to as part of something. So when we go over some of these word problems, you'll begin to notice that. So here I got first two example here. Okay, so basically these first two example is just for us to practice using the formula. All right, what number is 72% of 250? So whenever we deal with problem like this, okay, 72% of 250, just remember of the total. The total is referring to the whole. All right, so when you see the word of, just think of the total. Okay, of the total, of the total, of the total. So the total over the whole is going to be 250. All right, 72% is percent. So the only thing I'm missing here is my part. So in order to find part, we always going to take percent times the whole. What was going to take percent times the whole. All right, so if I got 72%, got to be converted into decimal notation, so that will be 0.72 times the whole, which is 250. So let's see what they're going to give me in the calculator here. Let me minimize, let me turn on my calculator real quick. All right, 72% of 250, so 72% is within 100. So my part, okay, it's going to be lesser than 250. Where's my calculator go? There we go. So we just say 0.72 times 250. All right. So my part is going to be 180. All right. Makes sense. My part. So whenever I have less than 100%, my part got to be lesser than my whole. All right, let's try this one. 714 is 85% of what number? So of the total, of what total? So that means this problem is actually looking for the whole. So if the problem is looking for the whole, 85% are percent. So that makes 714 as the part. So if I take my part, 714 divided by the percent, which is 85% in decimal notation is 0.85. All right, once I divide, I will get my whole. 714 divided by 0.85. All right, my whole is 840. There you go. All right, let's try a different kind of problem, okay? A sample of ore is found to be 0.0022% gold and 0.059% diamond. What is the percentage of the matter in the ore that is neither gold nor diamond? Okay, so that's actually neither. So basically, the percentage of that is not both of those. So that means the entire ore contains 100% mixture of different metal. All right, what percentage that is neither gold nor diamond? So we basically take the 100% minus the gold and minus the diamond. Okay, where's the 100% come from? Well, 100% is the entire ore. All the metal inside the ore together gotta be 100%. So 100% is 1 minus, all right, gold is 0.0022%. So if I move my decimal to the left 2 places, 1, 2, so that will be 0.1 empty slot. That will be a 0 right there. That will be 0.000022 minus the diamond, 0.059%. Move the decimal to the left 2 places. So decimal is here now. 1 empty slot minus 0.00059. So once I subtract off those 2 percentage, rest of it is going to be neither gold nor diamond. So I'm using 100%, which is decimal as 1 minus 0.1234 zeros, or 22, minus 0.00059. So that would be 0.999388. All right. So that's right. So this is not percent yet. So to convert into percent, I got to move my decimal to the right 2 places or times 100. So what percentage? 99.9388% are neither. All right. So this problem is just basically a subtraction of percentage, which does not imply to the 3 equation. All right, Melanie went shopping and spent $34 on sweater. If she spent $67 total, what percentage did she spend on sweater? So the sweater is $34. So in order to find percentage, so we normally take the part divided by the whole and make sure we times 100. Okay, that's from the formula above. So percent, I mentioned earlier, percent representing the part. So if I want to find the percent spent on sweater, that means my part got to representing sweater as well. So since I know Melanie spent $34 on sweater, so my part, $34 is representing sweater, divided by the total price spent, $67. All right, so what percent did she spend on the sweater? So that's $34 divided by 67, okay, times 100. Round to the nearest percent. So that nearest percent, so once I times 100, then that become percent, then I can round. So nearest percent is round to the nearest whole number, so that's about 51%. Okay, she spent slightly over half just on the sweater. All right. So that example is using the formula. Suppose 17% of students choose to study French in their sophomore year, And that meant that there were 153 such students. Okay, so what it's saying is the 17% study French in their sophomore is 153 students. All right, so let me write it out. I'm going to purposely write it out. Oh, freezing again. Is 153 students. All right, so earlier I mentioned the wording percent is a part. So if we know percent is a part, this right here, my 17% is a part. So that actually make 153 as a part. So that means I'm looking for, so that means what's missing here is the whole. So how many students choose not take French in the sophomore year? All right. So if 17% choose to do French, then my question is how many percent is not going to be French? So I'm looking from the percent perspective, okay? So if 17% study French, that means 83%. 83%. 83% is not. So how many students choose not to? Okay, how many students choose not to? So there are two things going on. I know 83% doesn't. Okay, 17% is 153. I need to know the total number of the students that's in the sophomore, that are actually sophomore. So so if my 153 was a part of the 17, if my 153 is a part, 17 is my percent. So that means what I'm missing was the whole, and this whole representing the total number of students, okay, in sophomore. So that's 153. Whole is part over the percent. 17% is 0.17. So once I divide 153 divided by 0.17, okay, that tells me there are 900 students, okay, total. So now 83% is not studying French, so I can actually take 900 total, okay, times my percent of that is not, times by 0.83, because now once I got my total, which is the whole, and I got my percentage, then I can say percent equal to then I can say my my part is equal to percent times the whole. All right. So let me go and figure out this answer real quick. 900 times 0.83. So the student that is not studying French is 747. All right. Or we could have just say, well, total was 900 minus the number of students that study French, which is 153. That will actually give me my number of students that does not study French. So there are two ways we can go about doing it, okay, once I figure out the total number of students. So if I do 900 minus 153, I get the same thing, 747. All right, whatever which way you like to do, okay, will work. All right, so we just kind of, I do want to show y'all, there are different ways to go about doing this, but the key thing for this problem is to make sure you understand the 17% is those 153 students. Therefore, percent is a part. That made 153 the parts. All right. 17 is a percent, so I'm looking for the total number of students that's actually sophomore. Then once I get that 900, I can subtract or I can multiply the 83% as not, either way. All right, this one says 38% of the trees in the forest are hardwood and the rest are conifers. What percent of the trees are conifers? So this is a name for this. This is actually called a complement rule. If 38%, this is called a complement rule. If 38% are hardwood, then how many percent are not? Or the rest of it are conifers. So the conifer got to be the total number of tree is 100% minus a 38% are hardwood. So rest of it, okay, which is 62%, got to be conifer. So basically, a lot of times, we can either sometimes subtract the actual amount to get our answer, or we can actually subtract the percentage, and then use that percentage to figure out our answer. There are basically two different ways to go about doing the subtraction or the adding to get our answers. Okay, so these are good examples. Okay, because these examples allow me to show you something called the complement rules. That's actually very, very powerful. For example, I can, instead of doing percent, we can use in fraction. So if a fourth, so let's say you give me a fourth, or you can say, give me a quarter. If you have a dollar, and give me a fourth, which is 1/4, a quarter, then how much money do you get to keep? You get to keep 3/4 of it. Okay, so the 3/4 is the complement to 1/4. Okay, give me a quarter, that means you end up with what? 3/4, because you take the whole thing, $1 minus the quarter, then the rest of it is what you got. So if 38%, okay, is hardwood, then the rest of it, which is 62%, got to be conifer, because the two numbers are complement to each other. Okay. All right, that will include this quick video on using the percent equations. Okay, so this is a quick introduction of these three equations. These three equations comes in very handy when it comes to finding part, percent, or the whole, and we tend to use them a little bit, okay, from time to time as we are moving forward this semester. All right, that will actually conclude this lecture video. Thank you for watching.